but we're not going to be able to. Yeah, we're not going to be able to do that. So my main thing for this is going to be go. I got a couple of things I'm going to show you guys today. We're going to go over chapter 1. I'm also going to do a little introduction for you to the Uglies book and kind of, I mean, we're not going to go through the whole book, of course, but I'm going to show you kind of some of the stuff that you can find in the Uglies book. Why I like it. It is a handy little thing. I mean, even if you're not doing like electrical all the time kind of thing, there's still other information in it. It's just it's I don't know. For the money, it's a pretty good little thing to have. But let me pull this up here and we'll get started. So, intro to the Uglies book. That's pretty much what they look like on the cover. They got the really it's only two formulas they use on there, and it's Ohm's law, which electrical wise is the most important one, and then they got another one called Joule's law, which is the power, where you see over on the side here where it's saying, okay, that's measured in watts, and really what is power? It's voltage times current, and that's like how much power you're using for something, and that's why like light bulbs, they'll measure them off. They'll say, oh, this uses so many watts, and it's like, okay. And you can even figure it out if you had like I don't know, a 60-watt bulb and you got 120 volts going into it. You can tell how much current that this light bulb is going to be pulling. But anyway, but yeah, this is the Uglies book. I do have a couple of I don't know quizzes, homeworks, I guess, that used where you'll have to go through and like find some information in the Uglies book. So yeah, we'll have. I think I have about 3 quizzes. I got like 1 extra credit assignment later on that you can get into with the Uglies book. But in the end, for everybody, pretty much, there's a lot of new terms and concepts that we'll be going over. So this is kind of like a little guidebook, if you will. I always used it like it was like my little on-the-job Bible. If I couldn't remember something, I'd just, well, I gotta go look that up in the Uglies book real quick. But I always had this thing in my tool bag. But so what kind of stuff can we expect? Well, this one, like right on the cover, that this is basically all like any calculations you might need to make. This wheel would show you how to do it. It's like if you want to figure volts and you got different, like, okay, I have power and current, or I got power and resistance, or I got resistance and current. I could figure out my voltages. And if I wanted to figure out how much resistance something had, I could go this way. If I wanted to figure out current, I can go with this. And if I want to figure out watts, if I have this information, I could pretty much work my way through it. So pretty much every which way you can kind of juggle it is kind of, like I say, it's right on the cover. But here's something. This is a representation of like a simple residential wiring, if you will. The side over here shows the transformer coil, and this would be literally like the transformer out on the pole, going into your house. And these would be the 3 lines coming into your house. So it's considered a single phase system, 3-wire. You got a neutral that's coming into your house, and that's a center tap on the transformer. And then we got 2 hot lines, if you will, 120 and 120, right? So these 3 lines are literally coming, whether it's underground or if it's on, but basically the transformer out in the pole somewhere around your house delivering power to your system. And this is what that would bring in. Uglies also shows you, like in industrial settings, you have like a 3-phase style. It'll show you that as well. So Uglies kind of covers, if you're doing residential, you're doing commercial, you're doing industrial, you're doing HVAC, this kind of has information for just about everybody, really. And this one's kind of an important one. If you have like because voltage isn't infinite. So if you have like a good run, right, you got to bring wire out 100 feet, 200 feet, 300 feet, so on. This calculation is how you would figure out how much loss you're going to get over a certain amount of line, okay? And they even show you down in here, like whether it's copper or aluminum. Hopefully it's copper because I cannot stand aluminum. But if you have to use aluminum, you know, if you're stuck using aluminum, you can do the calculations for it. And they go with pretty much for our region, this would be the standard temperature, you know, the 75 degrees Celsius. If you move somewhere else, you got to take into consideration the temperature for that area. Like if we were down in Arizona, the stuff in Arizona wouldn't necessarily work for here. You know, we're definitely dealing with some hotter temperatures. So you would have to be using a different part of the chart. But for voltage drop, see right down here, they go, and this is right in the Uglies book, you know, like I said, page 50, you can look it up. So, and if you ever had to do this kind of a calculation, right, you'd be able to pop it right out and say, okay, what is this? And this is literally a copy out of the book. So they go, okay, how much current do we have in the conductor, right, in the wire? Um, the L is for how long, you know, so how many feet are we running? If it's 500 feet out, well, throw that in there. The CM, now, the way they measure it's like the circular mills, so that's like how round, you know, how thick is this wiring, you know. So if you're using like a number 14 and number 12 AWG, you look it up, there's actually, you'll find it, it is measured in circular mills. So you need to find out what size wire you have, and that goes into this calculation. So everything stays the same. Really, the biggest one that's going to change on you is always what's the distance. And then you'll find out, and it's like, and later on we do an exercise where I even have you calculate through, well, if I want to have this much voltage out at this end, what size wire am I going to have to use? So even if you're an HVAC, right, you got to you're running from the service panel, and wherever you're ending up putting your unit, you're going to have to run that length, right? So you have to figure, okay, I'm running 200 feet. Is this size wire going to work for me? And otherwise, because if the voltage drop falls too low, it's not going to work because you won't have the right amount of voltage for that for your unit. So always when that happens, what you have to end up doing is going the next size up in wire, and then you could pop that in the format and go, okay, I got this size wire. Is this going to work? And you punch it through, and it's like, okay, yeah, that'll work. I got the right amount of voltage. So that's something we'll look at a little later. But again, this is all in the Uglies book. So see, like in this case, so here's an example, right? So if we have to figure out a voltage drop for a 240 single phase circuit, and we're using number 8, okay, THWN, which is for like outside, because the W is for wet. But and I want to deliver a 30 amp out over 150 feet. So they punch it all through, and we see I'm going to lose, and this is how much loss I would have. So if I run 240, I'm going to lose 7 volts altogether. And you can see it's in about 2.9%. And I'm allowed to lose up to 3. Anything over 3, and I got to go next wire size up. So this one just makes it, right? 2.9%. That's just an example. But yeah, this is all in the Uglies book. And that's why this thing is awesome. You literally have this thing right there. You just got to be able to know where to look it up at, right? And here's what, so when they talk about the circular mills, these are the wire sizes here. Very typical. I mean, you won't find every one of these in every house or at all times, but you could possibly find one of these being used in a house. The two most standards are number 12 and number 14 for most things in a house. But the way this works with wiring is the bigger the wire, the smaller the number. Like number 2 is some pretty big stuff, and number 18 is really small. So that's how they do wire sizes, and it's American wire gauge. So this is our when you look on the wire, you actually look on the insulation, it would have these numbers on it. It would say like number 14, and then you'd be able to cross-reference it. And again, right in the Uglies book, so I got number 14. what size is that circular mill, and that's their number right there, and that's what you would use to plug into this formula right here. So I tried to take away, you know, like I said, this formula right here is about the most complicated one we're going to use in this class, because you have to be able to figure out how much voltage you're going to lose over a given run of line. Okay, but it's really not that bad. The K part, the K, as you see right here, that's just for what kind you're using, whether you're using copper and aluminum. That number doesn't change, okay? And the current, you're going to have the current, right? You'll be like, okay, I got a 30 amp breaker in there, so that's what the current would be. So really the biggest mystery comes in is like on your wire size. And once you do that and you figure out, well, I got this much loss, and if it's too much, like I said, just you go the next wire size up. You just go bigger. But the reason you try to get it right down to the money is it's cost. You know, if the homeowner's paying this much, right, you're doing a job bid or something like that. Yeah, it'd be great if you could use like really big wire for everything, but the cost, right? So if your job bid comes in at X amount of dollars, you got to be able to run as tight as you can and keep it down to the smallest size wire that you can use for the whole job, right? So, okay. And here's a term. Now, this is our biggest term, okay? Now, we say watts. When we deal with watts, that's energy being used. That's when you're running something. So if I'm running my dryer, I'm running my stove, I'm running my refrigerator, it's burning watts because it's actually using, you know, current at that time. But now ampacity, you'll start seeing this on stuff, okay? You'll see this on your, you'll see this on AC units, you'll see this on furnaces, appliances, and stuff like that, where overall ampacity means I'm able to deliver this much. So when I have a circuit breaker inside of a panel and I go, okay, I got a 30 amp breaker in there. Does that mean I'm going to run 30 amps all the time? Oh God, I hope not, because your electric bill is going to be through the roof, okay? But ampacity means I can get 30 amps if I need it. So that's basically when we look at the service panel. So I got a 200 amp service coming into my house. Am I going to be running 200 amps all the time? No, no. But can I? Yeah, if I have literally everything on in the house all at once, right? My wife's gone crazy and she's got everything running, the washer, dryer, the stove, and everything else going, right? So this would be my ability to deliver. And so that's when we run across this term, that's what they mean, ampacity. It's like I have the capability of running 30 amps or 20 amps or 15 amps, depending on my breaker size. And it always comes down to the weakest link in the line, right? You got your circuit breaker, you got your wire, and then you got your device. So it would depend on what it is, but in a lot of cases, usually the weakest link is your circuit breaker, because it's saying, oh, this is how much you're going to deliver, and I've got everything else sized accordingly. So, but that's what they mean by ampacity. And that's our new term of the day. So when they measure this stuff, like in wire sizes and stuff like that, what they look at is ampacity. So when I say, okay, what can number 14 run? Well, number 14 very typically is hooked up to a 15 amp breaker. Number 12, very typically to a 20 amp breaker. Number 10, a 30 amp breaker, 8, a 40 amp. You see how that's going? So on and so on. And then we get down to the like really giganormous size, 1-aught, 2-aught, 3-aught, 4-aught. These are usually the ones running outside, you know, the one at Ameren or ComEd or something like that's bringing into your house, you know, down the mast and to your service. And that's pretty much where this wire size is going to end, these really large sizes like that, because you see the size on this here. 4-aught is up to 195 amps. So if I'm running a 200 amp service, right, I'm bringing in the big boys, but it's going to end basically coming into the service panel. And then from that point, I'm going to start running out with little wires, depending on what size breaker I have. But this is pretty much a golden rule here. We can pretty much match up. And again, the only time this changes is if my temperature changes. So like I say, so if I'm like out in Arizona, I would be like going in this area here, because heat changes stuff. And electricity does not like heat. The more heat there is, the less current I get. So when you're dealing in hot areas, you always have to go up in size. Like, see how that is with that? So it's like, So, but our typical region for Illinois, you know, we're pretty much running in this range right here. And then if we go up to like Alaska, then we go down. You know, like I say, it all depends on the region you're in. But that's what they mean when they say ampacities. So it's like what your wire size can handle and what size breaker we're going to go with that wire size. And we always have to deal with adjustment factors. And you'll run into that with different things, especially, you know, and with appliances and stuff like that, because they got some things where, you know, we may not be running things constantly, so we don't have to worry about adjustment factors. But if we get things where we have motors involved, we have to start adjusting, because that's considered things like continuous duty and stuff like that. You know, you get those blower motors going on your AC units or your furnace, right? Those things are running constantly, so we have to adjust. You know, we have to make adjustments for that. So the Uglies book, and like I said, and this is all in the Uglies book, which is really awesome. So you can literally run around with this, you know, and it's not a very big book, so you can run around with that thing literally right at your fingertips. You can figure out, like, if I'm running, even to the point where I'm running EMT, right, rigid. So if I have to run like conduit and stuff like that, it's like, well, how many wires can I fit inside of a 3/4 AMT? Okay, if I'm running all number 14s, all right, I could fit this many in there. That way I know, it's like, okay, what's my limit if I ever have to run into this situation? 9 times out of 10, though, if you're doing like residential, commercial out in this area, we're usually using what a lot of people know as Romex, or officially it's called non-metallic sheath cable. Romex is a lot easier, but what they mean by the non-metallic, it's like, yeah, we're not running in conduit, and it's sheath. It's just got you know, the nylon sleeve that Romex comes in. But that's usually what you'll be dealing with. But if you do have to ever deal with like conduit, this lets you know, let's say the pipe's already there and you need to run something through it to get where you want to go. And you look inside and it's got, you want to run number 14, but it's only got 18 wires in it. And you go, oh, well, I can get 22 in there. So you know you got enough room to be able to pull your extra couple of lines through if you need to. But it's got sizing for basically all EMT sizes and how many conductors it can handle and what sizes, you know, if you're doing, yeah, these number 1 is huge. So how many number 1s can fit in a 1/2 inch? Yeah, 1, maybe. And have fun with that. No. But yeah, this information is all, like I say, all in the Uglies book. I like to go through it, and we'll have like I say, I have a couple exercises where where I have you guys go through and look up stuff in the Uglies book and find the information, and it's kind of neat. And if you don't have the copy, I do have the electronic one available on the Blackboard, so you'll be able to pull that up too. And this book also follows the NEC. So every time there's an update in NEC, like this year, they got a new update, the 2020. So the Uglies book will be following along with the code and do any updates that it needs to do. But if you got an older copy, most times, unless there's like some real big change in the code, you know, it'll run through and it'll be pretty much standard. It probably hasn't changed. But it looks at aluminum or copper, or even more horrible is the copper clad aluminum. I'm just not a big fan of aluminum, but anyway. But even down to the point where, let's say you're looking at symbols, let's say you're looking at a building print and you run into a symbol you're not real familiar with, yeah, you can look up in the Uglies book and go, oh, that's what this is. So it has like most of the conventional symbols that are out there used on prints. You'll be able to go through and see like fan outlets, even down to the point like your receptacles, right? This is like your plugins. So how many styles they have and range outlets and whatnot. And you'll see they're very similar, right? So you don't want to get confused. And it's like sometimes they'll have little sub note to it and stuff, and you'll be like, oh crap, I don't remember what that means. And it's going to happen unless you're doing this, you know, looking at prints every single day. You're not going to memorize what these symbols are. I know even to this day, some of these symbols, no, I'm not going to memorize it. If I can look it up in a table, then that's all I need. But, and they even have to the point where we can do like maximum conductors in a box, you know, a regular, like an outlet box that you would have mounted within the house. It'll tell you how many you can stuff in there safely, because there's a code for that too. And so you don't want to overstuff a box. The inspector would come along and see that. And the worst thing you ever want to hear an inspector tell you, right? It's like, oh, no, you got to redo that. And like, son of a bitch. No. But yeah, it has everything measured out, and you could tell based on the size of the conductor, you know, how much space you have. But that's pretty much my intro for Ugly's book. And I just wanted to give you guys a little intro to it, show you what kind of information that we have in there. And I think next week I have your first exercise for the Ugly's book to go through. And I just want you guys to get familiar with using it and know where you can look stuff up. And there's still tons of other stuff in there, and it covers so many things in the electrical world. It's like depends on what you get into. But even if you're in HVAC and stuff, you know, if you have a copy of this book sitting in your tool bag or sitting on your truck or something, you always have it with you. You run into something like that, you could totally look it up and be like, oh yeah, I got that. But so with that, and we'll go talk about chapter 1, pretty much general information. As you guys gone through and seen in the homework, it's like getting used to, see, the biggest thing about the NEC is something I call, you know, and we don't talk this way normally day to day, right? Legal speak. Because everything's always like in legal speak when they do this crap. And it's like, well, what the hell do they mean by that? And that's, you know, I did the homeworks kind of to get you guys used to, well, how does it mean that? You know, and it's like, well, you got to be careful because some of this crap means one thing and you might think it means another. And it's but yeah, our number one thing always is, it really comes down to, it's about safety. Okay. Liability. You don't want to be responsible for burning down somebody's house, right? You don't want to cause a hazard. You don't want to get somebody electrocuted, yourself included, right? You know, one thing I always say, you know, worst thing about being electrocuted is A, you're probably going to die, and B, it's going to hurt the whole time you're dying too. No, but yeah, you got to be careful with this stuff. It doesn't take much current to go across your heart and stop your heart. It's down in the milliamp range, and generally when we're doing even residential, you know, we're way above milliamps. So you got to be careful. We always want to think about what we're doing before we do it. Yep, dangerous voltages in residential. We're doing typically 120 and 240, and yeah, those will kill you. And the bad thing is, the lower the voltage, the more likely it is that you can get electrocuted. Like 120 will grab you. I mean, it can grab you, and you would be amazed. And the worst part is, because all your muscles and stuff are all done by electrical, right? So when you're getting electrocuted, you have literally lost all control of your muscles. So even though your brain's sitting there firing away, telling, yeah, let go, let go, let go, you can't let go because you literally don't have any control of your muscles anymore. So, So, yeah, let's avoid that. Always avoid that. But anyway, so this one kind of goes back. Zach was asking me about the homework earlier. When you measure something, the way the meter works and looks at stuff. So a meter always measures potential or potential difference, okay? So when you have the meter, in this case, across here with the switch off, so on one side, you're going to have 120, and on the other side, you're going to have 0. What your meter is going to read when it's like that, it's going to read 120. Now, when that switch is closed, it's going to read 120 on both sides. It's going to tell you 0. But that's the way the meter works. So if you want to be able to read a live line, you have to have the red probe is always in the live side, and then you got to go to a dead side, like a ground or something like that. But this is a good way to tell if the switch is working. Is the switch off? If you popped across like that and you read 120, yeah, switch is off. You popped across like that and you read 0, yeah, switch is on. So it's kind of a weird concept, I guess, you know, kind of looking at it that way. I've been doing it for so long, it's almost like it's almost a no-brainer for me. But when you first get into it, it can be a little confusing because you would think, well, switch is off, I should be reading 0, and it's like, no, that ain't the way the meter works. The meter is measuring potential, it's measuring difference. So it sees a difference when the switch is off. It sees no difference when the switch is on. Just a little exercise, if you will. So when you go in and look at stuff, yeah, think about how the meter's looking at it. And we talk a little bit about arc flash. Now, arc flash is almost like a little lightning bolt that'll jump from one spot to another. Sometimes sometimes somewhere else. It can jump across air. Air can conduct. And you'd be amazed at how many things actually can conduct. But air can conduct. If you ever see service panels in like a store or warehouse or something like that, they'll have it like yellow taped in front of it. Yeah, 36 inches, because that's how far out an arc flash can jump. And that means that can jump to you. And when you do an arc flash, it can generate a temperature up to 35,000 degrees. Think about that. 35,000 degrees is enough to burn right through your bone. And I mean, and you can go online and look. There's pictures out there. Look at it, like arc flash injuries. They're really awful, but it can burn a hole right through your arm and literally seal it. You won't even bleed. It just have this big hole right in your arm because it's hot enough where it'll just fuse everything, and yeah, nothing will ever grow back. You'll have this giant hole there. So always be careful of arc flash, and that's when something jumps from one spot to another. But once that lightning bolt jumps, you know, and you get that potential, it can get carried away, because current likes to go, what they say is current follows the path of least resistance. And that means it'll jump wherever it can travel. And if it finds somewhere else to travel that's easier than where it normally goes, it's going to go that way. So don't ever give it a chance to do it. You know what I mean? And I don't want to scare you, but I do want to scare you. You know what I mean? It's just, it can be dangerous stuff. But usually if you're on a job, you'll go through the safety thing and watch the safety videos and see what the hazards are that you normally do. You know, and what's the rule of thumb here? It's like, don't do live work. Do not do live work. If you're going to go work on something, make sure that damn thing is dead. You know, you want to be isolated, keep it down, turn the breakers up, turn this up, make sure you're not working on live stuff, because live stuff is bad. I hate working on live stuff. It still gives me the heebie-jeebies even to this day, and I've been working on this stuff for almost 40 years now. But yeah, 4 main types of electrical injuries that they talked about here is it's shock. That's when you get a jump and it wakes you up and you go, ooh, that hurt, you know, but you didn't get hurt or nothing. It's just enough to jolt you, right? Electrocution, which can be fatal, doesn't have to be, but can be. But sometimes you will get hurt. That's when you end up with you know, the blood all popping. You see your fingernails go all crazy color. It'll even do like your eyes. It'll pop all the blood vessels in there, and you look like some crazy thing out of the movies or something. It could cause burns. And let's say you're up on a ladder and you get an electric shock, right? You freak out, and yeah, you end up falling off the ladder or falling off your lift or something like that. So even if the electricity didn't hurt you, it caused you to get hurt because it scared you. But so just things to think about, And then we cover, you know, it's like, well, if you ever have to deal with somebody that's been electrocuted, right, you know, and they're down, yep, definitely call 911. And yeah, your first reaction sometimes, and there's videos out there too, right? here's your buddy, he's over there, you know, he's stuck on a line. What's your reaction? Is to reach out and grab him, right? Yeah, don't do that. You know, I mean, you know, you want to grab something, if you can grab a piece of wood or something like that and like pop them off or something like that. I always told people, it's like, yeah, I like you enough. I'd whack you with a 2x4 to save your life. No. But really, I mean, right? It would be something you might have to consider. Yeah, definitely. The first thing to really try to do is always disengage that electric power, kill the power, and then yep, perform CPR if they're not breathing. Right? If you can get it, somebody's getting electrocuted, kill the power, get them off of there. Don't touch them, and yep, hit them with CPR, and hopefully help is on the way.
Or whack them with a stick.
You know, I've always said that. I said, I like you enough where I'd hit you with a 2x4. But I mean, the 2x4 is not going to conduct, so you can definitely get them off of.
They would rather have a broken arm than being dead.
Exactly. Exactly. So, okay. Electrical tools. Now, if you get a multimeter, they got ratings on them. Like, I always prefer. My meters have always had a Cat 3 and a Cat 4 rating, just because I like it. Now you can get away with a meter with a Cat 3 reading typically, but if you get like an industrial setting or, you know, higher voltages, like you're dealing with 480 or anything like that, you definitely want to have the Cat 4. The Cat 1, that's if you're doing like I don't know, really that's only like DC work, you know, if you're working in electronics or maybe like checking fuses in your car or something like that. Yeah, you can get away with one of these Cat 1s. Because remember, you got your meter on something, you know, you're checking live voltage. If your meter's junk, you're still connected and you got those wires and you've got that, you're holding that thing in your hand, you know, and that meter's junk and it could blow up in your hands. It could end up shooting electricity through it or something like that just because it can't handle the rating. So usually Cat 3 is the minimum. I prefer, you know, a good Fluke meter or a good Milwaukee meter that has a Cat 3 and a Cat 4 rating on it is always a good way to go. Yeah, we cover a little bit on electrical safety with this chapter. Lockout, tagout. Because even though you went, let's say, all right, so let's say you're working on the AC in the house, right? Panels out in the garage, AC units down in the basement. Now you go and throw the breaker, you lose what we call line of sight. Because now you're down in the basement doing work, you can't see up in the garage. So if some bozo comes along and flips the breaker while you're working, all of a sudden, you know, and you're thinking you're dead, and you go to start working on it, and you got live wires all of a sudden. So if you don't have line of sight to your switch, then you want to lock it out, tag it. You know, your tag is, I'm the guy that locked it out. Your lock's on there. There's no way anybody can throw it or something like that. You know what I mean? And they do make, they're weird looking little things, but for circuit breakers, even if you're doing residential, right, you got other contractors running around or something like that. And I don't know, the guy didn't know. He thought, he just sees a thrown breaker in the panel and he figures, oh yeah, I got to turn that on. It's like, oh Jesus. But they make their like, I don't know, they're little guys. They fit over the switch, and they fit so that way when the switch is in off position, and it'll lock onto that circuit breaker, and you can get them. They're pretty cheap actually. You get a little lock thing that goes on it, or even a zip tie. You know, that way nobody can just tug it off. So if you're, and it depends. You know, if you're in like a workplace kind of environment, you're doing. A lot of times the places will provide the different locks and stuff like that too. But it's always good to have them. And there are safety measures required by OSHA. And that's the thing, we start getting into this, you know, there's different safety organizations. Of course, OSHA is probably the most well-known one out there, right? The occupational safety hazard. But always practice, you know, good housekeeping on this stuff. Don't work on live stuff. Make sure you're locked out, make sure you're tagged, so that way they know, hey, you want to turn that on, you got to go talk to Jim over here, right? You got to talk to Bob. And it's like, okay. But yeah, it's always good. If you lose line of sight to your switch, the best way to go is to lock it up. And yeah, only qualified people usually are can work on energized or live equipment. And even then, you know, it's dangerous. You never know. You know, you can't. You have that one slip up, that one. What do I always say? You know, well, you get one chance, maybe. But yeah, and as you've gone through the homework, you see, yeah, NEC defines a qualified person, one who has skills and knowledge related to the construction and operation of the equipment and has specific safety training on the hazards involved. So that way he can be able to look at it and pretty much, you know, assess the whole situation and go, oh yeah, well, we got to worry about this and this and this and this. So if you are not that person, yeah, the best way to go is don't work on it live. And there's never really a reason why you should have to work on live stuff. I mean, if you have live stuff and you can check it, you know, use your meter. It's like, do I have voltage here? Do I have this? You know, but you're not actually getting in there. And then, yeah, if you have all the voltages, everything checks, yeah, then go ahead and kill it. And that's when you can start tearing stuff apart. And always make sure you have, you know, usually your workplace these days are pretty good. But sometimes you got to question it, you know, do they have the right PPE? Don't be afraid, you know, ask your boss or something like that. Because sometimes they didn't think about it or something like that. You know, it's never bad to be asking too many questions. I always say there are no stupid questions. There's only stupid answers. You might hear the other way around, but it's true. You know, if you're worried about it, ask. Seriously, ask. But they should have training on the PPE, how to use it. You know, it's your first time. What do you know? You've never used this before. Ask. Yeah, big rule of thumb. I always no bracelets, no rings, gold, silver. You know, it conducts. I had a I had a guy one time. He had a real nice gold bracelet his girlfriend gave him. Right, he's working and stuff. And I was turning around and looking at the schematic. While I'm looking at the schematic, I see this like bright flash go on behind me. You know, it just lit up, and I was like, "Oh shit!" And I turn around, and he's alive. He's okay, but he's got two arc welds that went across his bracelet where he hit it on the contacts of these two breakers. So the screws on those breakers were gold plated. Yeah, he gold plated those things from his bracelet, and he's lucky he didn't get hurt. But it was just the right amount of thing where he wasn't touching anything else. So thank God. But yeah, jewelry and electricity are never a good thing. So if you have your wedding band, you have, you know, something special your girl gave you or something like that, you know, have a special spot. If you got a locker, put it in your locker for the day, that kind of thing. Put it in your pocket, you know. She questions you. It's like, why don't you have your wedding band on? Because I want to live. No. But yeah, and you'll be going through them these days. After a while, you'll probably get to hate them. But safety videos and safety seminars. Most job places have them. Some places have them where you got to go through like every month, sometimes every couple of weeks or something like that, where they have different, you know, the safety topic of the month or the safety topic of the week and stuff like that. So it all depends on the workplace, but usually you have to go through, you know, a good safety training program, and usually you have to sign off or take some little quiz or something like that. But and there's a lot of different ones out there. I mean, like I said, OSHA is the biggest, right? OSHA.gov. You can always go on their website if you got concerns. Yeah, you do have the Center for Disease Control. That's a weird one, okay? But then this is one here, not many people think about it, the National Safety Council. They get their hands in there. And then the guys that write the NEC, it's the NFPA. But like I said, National Fire Protection Agency. But you'd be amazed at the stuff they have. It's kind of crazy. We'll get into that in a couple of weeks. I'll show you where yeah, what NFPA does, but they have a lot of different stuff. But yeah, that's the biggest rule right here. Safety cannot be compromised. You are not paid enough to die. I don't know how much they'd have to pay you, but it would, for me, it would have to be a pretty damn good amount because I ain't going to be able to spend it. So don't take chances. Always use the right tool. There's always a tool for the job. Always use the right tool, you know. Don't be trying to finagle something in there, you know. It's like, well, I don't feel like going out to the truck and getting that tool. It's like, no, 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 no. Go out to the truck, get that tool, you know, and always turn off the power. Always try to follow lockout, tag out, you know, especially if you lose line of sight. Line of sight, you can get away with just keeping a switch off or something like that. But you lose line of sight, yeah, you want to lock. I don't trust anybody, you know. This is my life.
Yeah.
So, and you're not in a hurry. There's never a hurry to be safe. Your boss is breathing down your neck. What the hell is taking so long? It's like, well, I'm making sure I'm assessing everything here, and I'm thinking about all the hazards, and you know, and most bosses, you know, they'll let you get away with it. It's like, okay, yeah, okay, good. But licensing and permits, and that's a weird thing with licensing, but like in most places though, in order to do, you know, contract work and stuff like that, usually you have to have a license. You know, electricians and stuff like that. There is a state license that you have to go and take and pass and be licensed to do that work. Otherwise, when you're doing that work and you're not licensed to do it, there's a liability factor, especially if you screwed it up. You know, you start looking at some hefty fines and stuff like that, and that's never fun. But yeah, most states and whatnot, you'll have to go through and get a license. I mean, you in this state, you even have to have a license if you're a beautician, okay? But so, and pulling permits, you know, and it depends on your area. Permits can be weird, but a lot of times you can check with the local county, that kind of thing. And believe it or not, if in doubt, when you really come down to it, if you call the local fire department, believe it or not, they will actually know because they would, you know, like especially like electrical and stuff like that. The local fire department would be able to tell you who the local like authority is or whatnot. They may be the local authority. Some cases, the local fire marshal or something is your local authority. And if he's not, he will know who the local authority is that you can get in contact with, and so you can pull your permit. There's different cities, different counties, different towns. It varies from place to place. It gets really weird. I know this is boring. I'm sorry, but yeah, usually you pull a permit to do the job. Usually you have to have the permit displayed in the job while you have the job ongoing until you know you're finished with it and whatnot. Any details you might need, or usually you have in your plans, your prints. You would go down and bring them with you to pull your permit. They probably take copies of it and keep it with. And then you may or may not, you know, it depends. You may or may not have somebody come by and inspect your work while you're doing it. Some places don't. You know, some counties and stuff are pretty poor. They might not have anybody that really goes through it, but always check. Always check and make sure. Make sure you have to pull the permit and whatnot. So many people do like what do you call it? Like, yeah, unpermitted, unlicensed work and everything like that. And it's like, oh my God. And then they wonder why their house is burned down. No. but but yeah, your plans are your prints and stuff like that usually have pretty much all the details for the work you're gonna do. Most places when you pull a permit do want some kind of prints or drawings or something, right? You just can't go in there and pull the print. I mean pull the permit. But and that's when we got into that homework. It's like specifications. What are the job specifications? And that's usually like a breakdown of what the job's going to consist of, you know, any special instructions and stuff like that. You usually go through and have specifications laid out, you know, something weird or something that doesn't just come right out in the prints. It's like, oh, well, this job is going to do this, this, and this, that kind of thing. But yep, so you should be able to convert a two-dimensional plan into an actual real deal. Because you go look at a print, you don't get a layout like this. It's not going to show you where the wires are going to go and stuff like that. It'll give you like the general location of where the outlet's supposed to be, right? But as far as down to the nitty gritty of where the wirings run, where any junction boxes may be and stuff like that, no, those are not. Those you generally have to kind of visualize and go through. Well, if I'm doing this room, I'm doing this, and that's what you do. So in your two-dimensional plans, they cover just like locations. It's like, well, we want this light fixture here, we want these receptacles here, switches here, kind of thing. But as far as all the runs and stuff, no, that's not on any of the prints you'll ever run into. It would be too much. It would get too confusing. So they use symbols and notations. And like I say, you can look up the Uglies book is a real good one for that. They do have a good couple tables and charts in the textbook as well. The Uglies book is just easier to breeze through and look at it. And believe it or not, online, you can literally pull up like so many different pages of symbols and stuff right online that you can look at real quick. That's a great thing about having smartphones these days. You can go ahead and pretty much pull up everything that there is out there and be right on the fly and go, oh yeah, that's what I'm looking at. But all those symbols, yeah, this is those organizations. You got organizations for pretty much everything. They got one, you'll see this word out there every now and then, ANSI. But yeah, it's American National Standards Institute. And believe it or not, they're the ones that do all symbols. Keyboard symbols on your computer are ANSI. Basically, any kind of, if your symbol's being used for something, it's probably on some ANSI chart somewhere. So you can always go back to these guys if you wanted to look up symbols and see what they mean. Yeah, you'd be able to pull it up with ANSI. But anyway, but yeah, when we go through and we look at our building prints and stuff, right? We all use all symbols to kind of highlight, you know, what we're working with. It'll be devices, appliances, any special equipment throughout the house, the store, the warehouse, you know, factory or whatever we're working on. and then really they don't change. I mean, really from house to storefront and stuff like that. The only thing that's changing really is the size and how much of it's used, you know. Otherwise, the symbology is pretty much the same. You know, receptacle's a receptacle, a switch is a switch, and they don't change from any of those. So if you end up working in any of those different environments and you look at building prints, you're pretty much looking at the same type of thing. Just there's a lot more pages of it, you know, the bigger the place gets. But anyway, so National Electric Code provides a standard, and it's a guidebook. It's a safety book. It's not. They'll be the first to tell you they're not a rule book. They're not the ones. It's like, you know, they can't enforce it. You know, there's no NEC police running around saying, nope, you have to do it this way. But they do provide a standard for electrical work to be done in a given manner. And their main purpose is, think about it, it's national fire protection. What are they trying to prevent? They're trying to prevent fires. And in the meantime, also other safety violations as well. But the number one goal is basically to prevent fires from happening in your home or in your workplace or wherever you have to do this stuff. Excuse me. So the NEC, yeah, they revise it typically every 3 years, unless there's been some major changes, and then you'll have, you know, a faster update. So if something crazy happened and we got something new going on, it might have been updated 2.5 years or something. But you pretty much rely on every 3 years to have a new code published out. And then you got these guys, where the International Association of Electrical Inspectors. And unless you go into that line of work, you know, you won't ever really deal with you'll deal with the guys that are licensed from these guys, right? They'll come out and inspect your work. But yeah, they do have an association for electrical inspectors. And in fact, the NFPA has a whole section or guide for different, residential, commercial, and industrial inspections. and each one's different. You know, it's like basically their guidebook to go through and do these inspections. But the NEC is laid out pretty straightforward. In the very beginning, you know, definitions are found in Article 100, which is right at the front. They have standards right up in the front in Article 90. And then after that, pretty much from 1 through 4 of the NEC applies to everybody doing electrical work, regardless of what you're doing. And then after that, after 4, then it starts getting specialized. So there might, if you're doing HVAC work, you may only deal with a certain section of the NEC after that. Or if you're an industrial electrician, you'll only deal with a certain section of that too. But 1 through 4 applies to everybody. Oh, I gotta update that.
Got a quick question.
Sure.
This PowerPoint, I wasn't able to find it. What folder is it under?
This particular PowerPoint right here.
Yes.
Ah. Oh, now you're gonna hold on. I do have it. Let me hold on. Bear with me here. We've got all right. All right. So here's your thing. Let's see. Intro to the not intro to the chapter 1 lecture notes. Should be the one that pulls up for you. You see that in Blackboard?
Okay. Yeah, it pulls up. I figured it was a different PowerPoint thing instead of the notes.
Well, the way I've got it, it's well, you see, it's like got the PowerPoint, and then there's a side where, like, if you wanted to actually print this out and take notes and crap.
Right.
Like that. So I do that, and even like see here the intro to the Uglies book lecture notes. Because
Gotcha.
I keep, well, this is mine. You won't see this on yours, but see how I have the actual chapter 1 lecture, which we're looking at now. But yeah, every one of them should have lecture notes notation like that when we go through the lecture, and that's what you would look at, would be that.
Okay. Alrighty.
Hey, gotta ask questions. How do we learn?
Thank you for that.
But yeah, well, we're just about, we got a couple more to go here. I think, yeah, just a few, but so yeah, electrical inspection. You know, when we get into this, see, the NFPA lays these all out by numbers, and all electrical stuff is under the 70s. So if you looked up NFPA 70 something, it would be electrical. They also have other areas like in the 80s and 90s, 30s, 40s, but that's all other stuff. But anything in electrical is always under the 70s. So the NEC is NFPA 70. And you see here, the electrical inspection code for existing dwellings is NFPA 73. Now you get out there and you'll start seeing a lot of places that you work at these days want you to be NFPA 70E certified, right? And that means you've gone through the section of the NEC that applies to safety and that you recognize it and understand it and are able to apply it. But everything that you run into as far as electrical work is concerned, it would be NFPA 70 something. And you look, I'll show you guys in a couple of weeks. We're going to look through and look at the actual NFPA site, and you'll see how much stuff that they actually have their fingers in. It's kind of amazing. But the thing in the US, none of these things are actually enforced. So, which is sad, but anyway. But this is what they do. They evaluate safety, fire, and shock hazards for electrical installations. So their concern is for safety, safety for you, safety for the people going to live in the house, and so on, fire prevention, shock prevention, that kind of thing. Basically to prevent any hazards from the work being done. So yeah, most times you're out there doing the work, you're going to come to hate the inspector, but he's got a job to do, and his job is to make sure that you're doing, you know, the proper work and stuff like that. I've seen it several times. You know, you get the contractor, he's all arguing with the inspector, and it's like, and they're actually arguing code and this and that. Oh, this is all wrong. You got to redo this. No, this is right. And then you see them going back and forth, kind of like an umpire and a manager arguing in a way. But anyway, but building codes. Yeah, there's more than just those guys. You got other ones that could technically be involved in that, although you might never even hear of them, right? Like International Code Council, you got the American National Standards Institute, you got the International Association of Electrical Inspectors, right? And there's so many organizations out there, nobody ever even realizes they exist, you know, unless you're actually in that particular line of work. But you can know your code definitions always under the 90 and 100. It's definitions and safety and stuff like that, which is in the very, very beginning of the book. So, and most workplaces you go to, you know, they won't have it on your truck. You probably won't have a copy of the NEC. But back at the shop, they usually should have a copy of the NEC, regardless of what you get into, if you're doing any kind of electrical work. If they don't, I mean, come on, the book's only 95 bucks. So every, you know, most shops should be able to afford to have one as part of the reference library that they have. But yep, and then read 110.3 section B. Listed or labeled equipment shall be installed and used in accordance with any instructions, included in the listing or labeling. And see, that's the thing about the NEC. It's what I always call, it's like legal speak, and really taking the mystery out of what they mean by that. So what that means is, if you're using stuff, like let's say I go and put a service panel in, and I got my service panel, and there's literally not one mark on there, no manufacturer stamp, no testing stamp, no anything, I would question it. I mean, because then that means somewhere along the line, this stuff is junk, and it could be causing a possible hazard. If we go, and that brings us to this next section right here. So they, you know, we'll use the abbreviation right here, this NRTL. And what it stands for is, Nationally Recognized Testing Laboratory. Now, one of the most popular ones that pretty much everybody has heard of is Underwriters Laboratory. Okay, so you go and use a piece of equipment and you don't see that UL stamp on it, I would question it. I mean, what kind of Chinese knockoff junk are we using here? And am I running a hazard by using this stuff? Because you don't know, if it hasn't been tested and approved, how do you know it's not going to, like, one day just burst into flames? And who's going to be the guy at fault? You are. Because why? You did the work. You installed it. So if your boss is handing off crap to you, question it, because when it comes down to the line, who's going to be the guy responsible? Is it going to be your boss? Hell no, it's going to be you. So if you don't see a stamp on there, and it doesn't always have to be Underwriters Laboratory, there are some other ones out there too, right? But look on the damn thing. There should be some stamps on there. I mean, manufacturer symbol, there should be the testing laboratory symbol, you know, inspection symbols and all that crap. If you literally have some piece of equipment and it has nothing on it, no, there's no way in hell. I ain't installing that. You bring that back to your boss and say, you install this. Because when it comes down to it, his ass is not on the line, yours is. So always look at your stuff when you're installing it. And I don't care if you're going electrical or HVAC, and the same for HVAC. You're getting a piece of equipment too. You're looking at it and there's no stamps or nothing on that. Yeah, bull crap. You know, question it. Just because your boss says to put it in doesn't mean it's right. And you tell them, no, there's no way. So this is the #1 big one, because with their stamp on it and you install it and the damn thing went up in flames, right? You're not liable for it in the end run because they approved it. So the liability falls back on the testing laboratory, not you. But if there's no stamp on there from those testing laboratory and you installed it, and well, who's the liable party now? You. So do you really want to go through and spend the next 20 years of your life paying for somebody else's house? I know I sure as hell wouldn't want to. So, and there's no reason why you should have to either. It's a simple visual. You get this thing, you know, and I don't care if it's a stupid little outlet box, right? Look at it. There should be a stamp on that crap. EMT, same thing. There should be a stamp. Somewhere on there should be a manufacturer's logo, and there should be one of these testing laboratories. And like I say, UL is probably the biggest one out there, but there's other ones too. And if you don't recognize it, right, like this is the day and age of smartphones, well, you see this weird stamp on there, I don't know those guys. Pop it in real quick, look it up. What's it gonna take, 2 seconds? And if it comes up and you go, oh, okay, these guys, well, then you know liability is established and you don't have to worry. And that's really what it comes down to. Because when you're doing this work out there and you're a contractor, and I don't care what trade you're in, when it comes down to it, the bottom line is you're the guy liable for this crap. And if something bursts into flames or causes, you know, or something happened and somebody got electrocuted or some crap, you know, when it comes down to it, you're the one that installed it. You're the one liable. Your boss isn't liable for this crap. You know, you are, because you're the installer. So, you know, make sure, protect, you know, I call the CYA, right? Cover your ass. It's a big thing. And I mean, you should always do that. I've always followed that. And it's just something you want. And I don't know. I know I'm rambling on here, but really, this is the bottom line here, guys. Always cover your ass. Because when you get out there, you know, your ass is on the line. Like I said, your boss is not on the job. He's not the one doing the installation. You are. So you want to make sure that you're not the one going down there and having to, oh yeah, this burst into flames and your insurance ain't going to cover the whole cost. Well, guess what? You're about to have a really, really bad day. But, and with that being said, I got a little pictorial, if you will. Need a couple of seconds here. Pull it up. And I call this, why do we have the electric code? And this is kind of a, nope, come here, you. Kind of shows you like a few, oh, good Lord. Oh, give me a second here. And share that. So, yeah, the following slides are going to give you some reasons why we have a national electric code out there, okay? And yes, these are actual, I swear to God, actual pictures of crap that people had on there. Now, if you look at this, this is the main line coming into the house, okay? And they got these couplings on there. So this service is actually going out to the transformer on the pole. I shit you not. And those are vice grips locked on to that clamp on there. And yeah, the vice grips literally have no insulation on them. So anybody comes along and grabs this, guess what's going to happen? And yeah, this is a real deal. And this is actually clamped on and holding that service in place. Here's outside seal tight, where it's that flex tubing with the nylon insulation around, you know, to keep moisture out. And somebody literally hammered it into a tree so damn tight that you know it's got to be crimping the wires on the inside, right? Yep, these are, I swear to God, these are actual things that people have done out there. Remember earlier I was talking about with the Uglies book on box, how many conductors you can fit in a box and stuff like that. Yeah, can you imagine having to cram this crap in there? And there's a lid that's supposed to go on the top of on the face front of this box, by the way. So trying to picture cramming all that wiring in there. Yeah, there's NEC defines a limit on how many conductors are allowed and how much of a space. And there's a reason why. And yeah, this is actually a service panel. This is the circuit breakers and whatnot. And they literally, and you know, on the whole sides of these service panels, there's knockouts and everything where you bring the lines in and you have connectors, you know, to make it nice and neat and pretty and safe. But with this, you cannot put the front on this thing. So all this stuff is wide open and exposed. You know, you got all your voltages right out there. So anybody could just come along and or something could fly in there. I don't know. You have a bird fly in your garage and hit your circuit breaker. It's like, well, there's the end of that.
Have enough fun just tracing wires in that.
Huh?
Have enough fun just trying to trace a wire through that.
Oh, I know, right?
Take you
Yeah,
5 minutes just to find
yeah,
the
reverse engineer it. And here's
5
one.
minutes or anything.
And this is real nice and neat and pretty, right? So where's the problem? Well, again, you're only allowed so many conductors in a line. and and you have, I mean, look at it. It's literally so much that it's literally dimpled the whole top of this service cabinet. It's like he's got so many crammed in there that it's so tight. And you know, part of the problem is it's when conductors get hot, they expand. So you got all this insulation going on in there. And so if these conductors ever start getting hot and they swell up, and you know, and then they get cold and they go back and swell up and back and forth and back and forth. What ends up happening is it breaks the insulation after a while. Because that stuff is usually pretty strong, but it can only handle so much stress. And that's why, again, you have like several, and if you look, you got several knockouts on all service cabinets. And if you don't have knockouts, there's a lot of equipment, even if you have to use a hole saw, right? You can still cut different holes and stuff like that. But anyway, I just enjoy these pictures. And this guy, so you are allowed one extension ring on a box. On one extension ring. This guy got creative, and I don't know what he built. But, oh, I know. I got a couple of videos later on we'll look at too that are just, it's too much. Nice and pretty, right? Yeah, where's the problem? I'll show you, but it's real nice, neat, and pretty, okay? So you got your meters, right? Your disconnect. So, all right, so picture this scenario, if you will. What should happen, one, if this AC unit were to burst into flames, how am I going to turn the power off? Right. So your disconnect should never be over something that is disconnecting, because you have to be able to reach it to turn the power off. And again, the other problem is it's right under the main meter feed here. This is where the service is coming in. And again, if this bursts into flames, how am I de-energizing this thing? Yeah, it's just gonna, it's gonna explode if it ever happens. I don't know. So the rule of thumb is you cannot have anything in front of your service cabinet for 36 inches. Nothing. We have a rigid pipe in front of this bad boy. Yeah, that's not allowed. And then this one, oh yeah, you're supposed to, oh my God, the things people do. But yeah, you're supposed to have a given clearance when dealing with like areas with moisture, with wet. So that way it doesn't ever come into contact with wet. What do you suppose ever happened if we had a little buildup of water in this situation right here? I mean, you literally are like, not very much, if you could see by the tape measure there. Now this one would be okay. It's the one underneath that we have a little trouble with. But yeah, I swear to God, these are actual real deals that, you know, get called out. And I don't know what the hell went on here. I swear to God, I don't know who to beat, the Ameren guy A for installing this, or the guy that actually installed this on a pipe with a plywood backing. That's a meter. Yeah, I swear to God. And it's like, really? Yeah, and who do you get more mad at? You know, because, and some people say, well, Ameren or ComEd, they won't do it. Bullshit. They get paid to install stuff. They're not inspectors or anything like that. They're just trade guys too. They get paid by the job. So are they going to install it? You bet. Because who comes down to it? The customer wanted it. Yeah, here you go. So that's they call these, when you start getting into bigger sizes, instead of having like a bend, they call these things LBs, and they got like a little unscrewable cover to it. So that way you can route the cable through it. Because the cable, even though it's stranded, it's still pretty stiff. But A, that cover's gone. And B, your supports are completely missing. And you know that pipe's got to be cutting into the insulation on over there. So eventually, this is just going to be a bad situation for somebody. But that's why we have the National Electric Code. To try to protect people from themselves, because they're dangerous out there. You know, and even if you're not going to be a regular electrician when you do this work, you want to make sure it's a good job. You don't want, you know, the bottom line is safety, fire prevention, and shock hazard prevention, right? You don't want to burn somebody's house down. You don't want to cause somebody to get electrocuted, because really the bottom line, it's liability. And when it comes down to it, and they want to come back to you, right? You're the guy that installed it. You're the guy that's going to get in trouble. So always take, you know, kind of think in the back of your mind when you do this stuff. What am I dealing with here? You know, how do I keep it safe? How do I keep me safe? How do I keep my customers safe? And that kind of thing. And that's really what it comes down to. And that's why we use the code. And really, that's the thing I'm going to be showing you guys over these next few weeks, you know, how to keep yourself safe, how to do proper installation, how to be able to look at the stuff and calculate it. And like I said, we're not going to get really complicated with calculations. That calculation I showed you earlier for the voltage drop is about the most complicated we're actually going to get here. And I mean, a little later, we'll do an exercise I call the service entrance deal. So you have to actually figure out how many amps your installation is going to cost you. So how to figure it out, and how to be able to figure out, oh, do I need a 100 amp service, a 150, a 200, or what? But we'll get into that and basically show you how to do that kind of stuff through the class. I think it's kind of fun. And plus, you'll learn a few things. And then most definitely see some more pictures and videos of people doing the wrong thing. There's lots of that. And generally, it's usually the homeowner or the business owner that went ahead and decided he could do it himself without knowing really what he was doing. But that's chapter 1. It gets us through like safety and how to think of safety, introduces you to the Uglies book. I like using the Uglies book. I always, for every, even when we were in class, for every quiz and test and all that, I always, you know, you could always have your Uglies book with you. I figure it's like, yep, you're going to use it on the job, you're going to use it in class, use it in lab. And that's what I have for you gentlemen today, you folks and ladies. But anybody have any questions, or that seemed pretty straightforward for y'all?
The drawings, I noticed those, we're going to have those Monday.
Yeah, we're going to start. Well, I wanted to kind of go over some stuff, and then we're going to have, I got 3 exercises kind of asking you to, you know, get into it and getting used to looking at some of the details and stuff like that. Basically like asking you to find stuff in the prints. You know what I mean?
What drawings were you referring to?
Well, the textbook comes with 10 drawings, okay? If you don't have the textbook, hold on here, I'll show you. I will show you. Where are we at here? I gotta find, bear with me. I gotta find all right. So when you look at my thing here, we got announcements, course information, you guys can all see this, right?
Mm-hmm.
Okay. So under course information, that's where I've got the syllabus, you know, kind of, and even a layout, like what chapters we're going to cover over the weeks here, okay? My grading policy and stuff like that. But I also have a thing in there like how to measure with your digital multimeter the proper way, you know, looking at things like switches and fuses, which can be a little confusing. But this will show you how to do that and how to connect to terminals. And always remember when you use your digital, little side thing here, but if you use your digital multimeter, do not check ohms on live circuits, not unless you feel like buying a new digital multimeter. Because what it'll do when it checks resistance or ohms, it sends out an electrical pulse. And so when you switch and you hit it like a 120 on that, that circuit that's on that meter will not be able to handle that. And I guarantee you, if you're lucky, you just blow the fuse on your meter. If you're unlucky, you fry the board on your meter and you're going to get a new meter. But so never, ever, 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 ever check for resistance on a live circuit. Now, if you need to check a fuse, what you do is you put it on voltage setting, okay? And you have your two terminals on a fuse. I don't care what kind of fuse it is. You got slow blow fuses, you know, the glass poppers or anything like that, the melt-aways or anything. You got two terminals on end to end, okay? So if you go across with your red and black probe on a fuse and put it on the voltage setting, and I don't care what voltage you're measuring, and it shows zero volts from end to end, right? That fuse is good. That means you have 120 on both ends, or 240 or 480 or whatever the hell it is. If you go and measure across a fuse and it does show you a voltage, that fuse is popped, because that means one end is acting like a ground. So that means you got voltage on the one end and nothing on the other. And the way your meter works is it looks at potential difference from end to end. So if there's a difference, it'll show you what the difference is. If it says zero, then you're reading across something and you're pretty sure it's live, and it's live, all right. Don't go sticking your fingers on there. Anyway, and under course content here, that's where I have electronic version. I got the textbook, okay, but I have, see this one here, for building drawings. And I've got all the copies of it. There's 10 drawings all together, because we basically have the prints for a house. And it's a really nice house too. This house has all the bells and whistles. We even got a swimming pool. We got a sauna, a swimming pool, full ranges, appliances out the wazoo. I mean, this is a really nice house. I think it's like about 3,600 square feet, something like that. So it's a good size house. So it's got all the, you know, pretty much, well, the reason being is to be able to show you everything that we could possibly run into, right? But we're going to look at, I think it's drawing 6 and I'm trying to think off the top of my head. I think drawing 10 will be like a homework exercise or a lab exercise, if you will. And I just want you to be able to look at, you know, be able to get used to being able to look at a set of prints and being able to pull details out of it, you know, stuff that's relevant for you. And it doesn't matter if you're going to be an electrician or an HVAC guy or whatnot. You're still always going to have to look at building prints, you know, and it doesn't matter if it's a home, a store, a warehouse, a factory, or whatever. You know, there's always building prints, and it's going to tell you where, you know, where and what your equipment is that you're installing or you're repairing. And you have to be able to go into the prints and at least be able to recognize the symbols you're dealing with and being able to read it. So that's what we're going to do. But yeah, in course content, and I also have a copy of the Uglies book if you don't have that available. It's a 2014 version I had on electronics, but it still works for everything for the class. But yeah, so if you don't have any of these things, that's where I have them all for you guys to use. So it's all online. And then if you haven't gone through it, so I do the announcements. I usually email those to you, but if I have something special coming up or something, I'll usually post something there for you guys. The course information is the syllabus. This is course content. And then when I got daily course content, and I don't have everything posted homework wise yet, but for the next up to day 4, I have everything posted for homeworks, but I have it laid out for each day. So you can go in day 1 and day 2 and 3 and so on. And then the other area, and you can thank Stevie for this because he made me do it. No. was putting a course calendar on there for you guys. So you can pull your course calendar up and you can even see when all my due dates are for all the homeworks and stuff like that. And like I said, I got the next 2 weeks covered. I don't have everything posted yet, but so that way, if you're, you're wondering if, oh, do I have a homework due or something like that, you can go on the course calendar here and check. And I've got it all laid out, and that way you can keep on track with anything. And like I say, it's not set in stone. So if you got something coming up, I don't know, family emergency, work got in the way or whatever, right? Just hit me up and text me, email me, hell, call me, something, and let me know, and we can extend the dates out and stuff like that. That's not a problem. I just don't want, I gotta have due dates on this stuff because we got to keep up with the pace of the class if we can. But if you need an extra day or something like that, it's totally workable. All right. But that's how I got everything laid out. So, and if you have any trouble with that, let me know. But otherwise, I think it's pretty straightforward. And like I say, we'll do, usually what I have you do is, like today we just covered chapter 1, but you already did the chapter 1 homework. I like you to go in and kind of do the homework first and kind of get into the chapter a little bit. And then that way, when we get into the discussion of the chapter, that way you can start asking, if you have any questions or stuff, we can go over it then. And something's not making sense, and we can go through it and, help everybody out and help yourself out with like, oh, because maybe other people were having the same problem, and was just, but that's how I have it set up, and that's how we're going to do it. Does that make sense?
Yes, sir. On the that course calendar that you're showing us, says for next Wednesday it wants us to have drawing 6 out of 10 and 9 out of 10. Does that mean like you just want us to have it printed out, or?
No, there's gonna be, it's questions, and see that there's another one too, the chapter 2 structure. That one's also on the print. No, but it's like a homework, it's like a homework style deal where I'm asking you certain questions about that drawing. So you'll be able to pull up your, like, say, drawing 6. And I think I got, I can't think of, like 2 or 3 questions only. But I'm asking you like a certain detail about that drawing. And I want you to find that information on there. So it's kind of like a lab homework style setup. So for each one of those, yeah, it's an actual question about that drawing. So you'll be able to go through and look through those prints that I showed you. Yeah, look through that drawing 6 or the drawing 10 and then, or drawing 9, I mean, and then it'll ask you certain questions about that. There's not a lot, just like I think I have like usually 2 or 3 questions about each drawing, but those are the most relevant ones. I would just want you to catch out some detail, kind of force you to get used to using the prints a little bit. You know what I mean?
All right. So I guess what I'm confused about is those questions. Are those being asked on Wednesday? Because I don't see where we're prompted to go do that. As like an assignment.
I'm with you. Hold on. Where I have them posted. All right, hold on here. We gotta show you. So here we go. Yeah, no, where I have the actual, see here, it's day 3. And then I got drawing 6 of 10, drawing 9 of 10, and then chapter 2 structural features, and also the chapter 3 homework. So for, yeah, next Monday's assignments would be those guys there. See, the course calendar can be confusing because that's when the due date is, right? But the actual assignment, yeah, I go through day by day.
Okay.
I can promise you every day that we have, I'm going to have some kind of an assignment. No. Well, it's just because I got, we got 8 weeks and I got a lot of stuff I got to cram in you guys' head because we're literally, we're going to get to the point where one of our more final exercises, I got like a 3-page exercise where I'm going to have you size this house based on those prints. And I'm going to have you size a service entrance, like what kind of service you need. Do you need a 200 amp breaker or 150 or what? And it's going to be based on your calculations. Everybody usually does pretty good with it. It kind of it might look like it's like, oh my God, there's a lot to this, but usually it kind of flows through and it's based all on the prints. So you got to be able to look at the prints and size like the appliances, right? So washer and dryer, size, what are your weird ones, right? The AC, the furnace, the washer and dryer. You got to go through the kitchen, and that's where your crazy stuff is. Everything else is all like just branch circuits, bedrooms and stuff like that, where it's nothing. But always your biggies is usually your utility room or laundry room, if you will, whatever you want to call it, and then your kitchens and bathrooms are like your oddballs out. But we'll get, that's later down the road. But you will actually be doing it, and it will be based on those prints. So you're going to be, and that's why I want you to get kind of used to looking at them, because when we get that 3-page exercise, you're actually going to be going through and looking at the prints and going, all right, what the hell is this? But you're literally going to make, you're basically going to do your own like service cabinet. Basically, how are you going to stuff it? What kind of breakers am I going to have in here? Because really, that's what it comes down to, right? It's easy to run wire. I can run wire from A to B. I can get a monkey to run wire from A to B, but is it the right wire? And then being able to size your breaker right. And even if you're just doing HVAC, you're pulling a line, and that's the other thing we're going to look at too, right? Is AC and furnaces, and being able to size it for the proper rating with the right wire size, the right breaker size, and the right installation for your unit. So and that's why it's important. So yeah, and we're going to get into all that, and that way, yeah, you'll be able to pretty much look at your house, which is what those drawings are. Basically, consider that this is for this class, that's your job bid. That's your house. That's the house you're gonna do. All right.
Sounds good.
Yeah, I know. I don't want to. Don't be scared. We're doing it. It's gonna be all baby steps. We're gonna go pretty simple here. We go look at each one. We'll look at like doing like lighting branches and stuff like that. How we size our receptacles and things, and we'll take all the mystery out of it and all that. So, but yeah, we'll get into. I promise you, we'll get into what the proper installation is, and so you know how to do your whole house, basically appliances and all from start to finish. All right.
All right. I actually do have a question. It looks like you changed the homework 1 due date to Friday.
I did because some people got off to a bad start, so I was like, okay, I'll push it out because I know it was due today, but I had some people that didn't realize class even started on Monday.
Okay.
Yeah, and it happens. It happens. So yeah, I pushed it out. So if you were behind, it's a redo, but that's all it is. Otherwise, everything else will pretty much stay on track. Unless, like I say, unless something comes up,
Right.
people that couldn't do it, then I'll push it out. Usually, but just by a day or something like that. But yeah, that's why that changed. Yeah, I know. Normally it wouldn't have happened, but yeah, I think
Okay.
3 people miss Monday.
Sounds good. All right.
All right, guys. Well, you guys have heck, I guess you have a good weekend and all, and I'll see you all on Monday, huh?
All right. See you Monday, 1 o'clock.
All right.
Take care.
Bye-bye.